Hi there team, I just want to start off by going over adjacency matrices again. I've gotten you to do the questions in the Cambridge book and on review of that I found that that wasn't a good idea because Cambridge actually has it in there incorrectly compared to the current curriculum. So I want to just go over this again, spell it right. So we're going over adjacency matrices. So if we're given a graph that looks like this, so we've got A with a loop off of it, an edge that joins A to B, and an edge that joins B to C, and then we've got an isolated vertex at D. So if you've got that graph given to you and it's you're asked to make up a adjacency matrix, what you will have found is that Cambridge does it very differently, and it is incorrect in terms of the current curriculum that we are studying. So here's just a review on how it should look. So from A to A, we've got 1. So there's one way to get from A to A. Now, Cambridge will have this different. I don't want to talk about it because I don't want to confuse you, but stick to what we do here. So from A to A, there is one way. From A to B, again, there is one way, so we put a 1 there. A to C, there's 0 because there is no edges joining A to C directly. And A to D, again, there is 0 because there's no direct connections from A to D. We could actually go along, and because D is an isolated vertex, just put zeros down the column. Slight delay there today, and zeros along the row because there's no way to get from D to any other vertex and no way to get from any other vertex to D. Okay, so let's look at B now. So from B we can get to A, there's one way. B to B there's 0 because there's no loop there. And B to C we've got one way. Okay, let's now move down to C. So from C to A we've got 0, there's no direct edge. From C to B we've got 1, just this edge here. And C to C, 0 because there's no loop off of C. And that gives us the adjacency matrix for that one. Nice and simple. Let's just have a look at one more example from the Nelson workbook. So A, B, and C. So from A to B we've got an edge. And from A to C we've got 2 edges. It's a multiple edge. And then from B to C again we've got multiple edges. So let's go ahead and draw this adjacency matrix. So we've got our vertices A, B and C, and A, B and C. So from A to A there's 0. There's no loop off of A. From A to B we've got 1 edge joining A to B, and A to C we've got 2 because we've got those multiple edges. So that's a 2. So then we go on to B. From B to A we've got that 1 edge. B to B we've got 0. This isn't a loop, this is a multiple edge, so you need to be clear of that. It does actually come into vertex C. So B to B is 0. And then when we come to, come on computer, yep, 0. And then B to C we've got those multiple edges, which means we've got 2. Just there. And then when it comes to C, so C to A, we've got those 2 edges again, so multiple edges, so we've got a 2. C to B, again, we've got multiple edges, so that's 2. And C to C is 0 because there's no loop off of C. So that will be our adjacency matrix there. If you actually come to the end of each row and add those up, so if it's A is a 3, so you can see that A is a degree 3. B here again is a degree 3, and that's a 3. And C is a degree 4. So you got 1, 2, 3, 4. So that's just another nice little way that you could check that you've correctly made your identity matrix for your graph. So just those 2 little examples. So if you have looked at the homework and your answers aren't matching the answers in the back of the book, that's a good thing. Remember that a loop will only count for the one edge, not 2. It's only 1. A loop is not 2. Excellent. So that's the adjacency matrix. We'll move on to our next part of the lesson that we did. So I'll see you at the next video.